Hello, I'm Greg. In this video we will create a multi-threaded audio player in Java. With threading, more than one sound clip can be played at the same time. Eclipse is the IDE used in this video. First, the sound files are added to the project. Without threading, an audio player object is created and the file location is set to play the sound. If two instances are created, the second sound will not play until the first sound is finished. The audio player thread uses a runnable interface to create the audio player objects. An array list of audio player thread objects is created to bundle the threads for easier execution. A delay is set before running the threads. An additional delay of 50 milliseconds is added to the beginning of each thread. Each thread is started within a loop, and then the thread is removed from the array list. Finally, the array list is cleared. To start, let's create a new Java project. This project has been tested in Java 1.8 and Java 12 environments. A new class is created called Audio Player. The audio input stream uses the audio format and length to keep track of the last byte that was read. The audio format determines the type of audio output. It looks at encoding, channels, sample rate, and other audio file properties. The clip interface represents a data line that loads the audio file before playback, instead of just streaming the file in segments. By preloading the file, the clip is able to play the audio at any position or create a loop. A Boolean is used in combination with the do-while loop to verify when the file is completed. If this is not added, the program will prematurely terminate the audio. A private method is created called setInfo that requires a file parameter and returns a dataline info object. Dataline info contains the audio format and internal buffer size. Get the format by getting the input stream of the audio file. Systemprint is useful here to check if the file exists. A public method is created called setFile that requires a string parameter for the file location. A new file instance is created using the path. The dataline info is set with the file. The clip object is the dataline info cast to a clip class. The clip is opened, acquiring the required system resources determined by the input stream. A line listener is added to the clip to listen to the play status of the audio file. The audio player class needs to implement the line listener interface. Line listener contains a single method update that can notify the program when the audio file starts or stops. Include the catch exceptions to setFile. A public method called play is created to play the audio. Clip.start plays the file. A do-while loop is used to prevent the program from terminating before the sound is finished. An arbitrary value of 25 milliseconds is used to sleep while the sound is playing. Finally, close the clip. The update method checks for the file complete event. This is an indication that the audio file is no longer playing. If the file has stopped playing, set the Boolean to true. To test the audio player, create a new Java class called app. Inside the class, create a public static void main method. Retrieve a sound clip. There is a link in the description for the audio file used in this project. Copy and paste the sound clip to the project. Create an object of audio player to test a single instance. Set the file using the file location and play the audio. For multi-threaded audio, let's go back to the audio player and add a new class to the bottom of the file called audio player thread. This new class will implement the running interface. We will add a string variable for the file location, as well as an audio player object and a long variable for an optional delay. A constructor is created requiring a file location parameter. We set this to our class file location. A second constructor is created to overload the first and add the string location and the time delay. We set these values to our class variables. In the run method, let's include the optional delay surrounded by a try-catch block. Below that, the player is initialized and set, then play the audio. To test this, we go back to the main method in the app class. Create an array list of audio player thread objects called threads. If using a Java environment prior to Java 7, diamond syntax may not be allowed and requires typing audio player thread in the empty angle brackets on the right side. We define a number of threads and create a for loop. We add new audio player thread objects to the array list inside the loop. A delay is set before running the threads. An additional delay of 50 milliseconds is added to the beginning of each thread. The threads are started within a loop, and then the thread is removed from the array list. Finally, the array list is cleared. This concludes the video. Thank you for watching.